Hello and welcome to another episode of Mathematics Made Easy by Sir R Squared. In this video, we're going to discuss about rotation of axes. Dealing with inclined plane problems in physics can at times be very difficult and very confusing. That is why we need to review our geometry in order for us to clearly visualize what are the forces that are involved in the given inclined plane problems. In this slide, we're going to discuss about rotation of axes. Suppose that we have this one as our inclined plane. And this angle here is theta. Now, suppose that we're going to drop a line that is perpendicular to this surface. Let us try to do that. Suppose this line here is perpendicular to this surface, meaning to say 90 degrees. Now, if we drop another line that is vertical, okay, perpendicular to the horizontal, this one, the black one, and if we try to draw another line that is horizontal line, and they have this as their point of intersection, let us try to analyze now what is happening to the angles. If this is theta here, what can we say about this one? Actually, this one is also theta. Okay, I hope you can visualize that very clearly. This is theta also. All right. So if that is theta, now let us try to visualize this one. If this one and this one is perpendicular, meaning to say 90 degrees, and this is theta, what can we say about this angle here? This angle here is actually 90 minus theta. You are correct. This angle here is actually 90 minus theta. Pardon the handwriting. Now, let us continue our analysis. If this is theta here, what can we say about this one? Actually, this one is also theta because they are alternate interior angles. And according to geometry, alternate interior angles are always congruent. So let us try to draw it here. This is actually theta also. Very good. All right. Now, let us try to visualize this one. If this one and this one is 90 degrees, and this one is theta, how much is this one? This one is 90 minus theta. 90 minus theta. All right. Now, how about here? If this line here is perpendicular to this line here, and this line is theta, how much is this one? That is actually 90 minus theta also. This is 90 minus theta. Pardon masyado pong madulas yung aking sinusulatan. No? 90 minus theta. Now, what can we say about this one here? If this one here and this one is perpendicular, okay, that is why this is 90, and this is 90 minus theta, this one is actually theta. All right. This one is actually theta. Let's get another color. This one is theta. And if that is theta here, what can we say about this one? They are alternate interior angles. That is why this is also theta here. And what remains here is 90 minus theta. I hope with this, we have explained what happened to the angles that are involved in the rotation of angles. Ano? So if we drop a line that is perpendicular to the surface, and we drop two perpendicular lines, a horizontal and vertical, this is what is happening. This one is congruent to this one, and this one is congruent also to this one, as well as that one. And if this is 90, and this is theta, this is 90 minus theta, and so forth and so on. I hope in this slide, I have shown on how to rotate the axis, and on the future problems in physics, it is very easy for us to visualize what is the angle involved in the solution of the x and y components of the weight. Right now, we're going to analyze the forces that are involved on inclined plane problems in physics. So after having shown the rotation of axes, it is very easy for us to visualize what are the forces involved. Suppose that we have here as angle theta. All right? Now, and suppose this block here is tending to move. The acceleration will be going in this direction, going there. Okay? Therefore, there will be a frictional force. There will be a frictional force that will be opposing that motion. It will be F, and that is actually equal to mu n, wherein mu is the coefficient of friction and n is the normal force. Okay. Now, suppose that this is the center of gravity. Of course, it will be having its weight directed vertically downward. It is vertically downward. This is the weight, which is equal to mg. Now, if we try to draw the components of that weight, let us have that as a red one. It will have its, this one, pardon the drawing. This will be W sub y, and this one will be our W sub x. Actually, you can write the W sub x here and write there as our W sub y there. Now, for clarity, I just draw it here. All right. Now, in the previous slide, we learned that this one is actually theta. Okay. So the normal force, of course, will be acting perpendicular to the surface. Okay. Perpendicular and away to the surface. It will be acting upward somewhere here is the normal force. There you have it, the blue one. That will be our normal force N. So we have a W sub y that is acting actually, let us try to project that here. That W sub y, and the normal force is acting perpendicular to that surface. W sub x, if we project it here, it will be something like this one. W sub x. If we try to analyze this triangle here, this one, this triangle, we can see that we will be having a triangle that is like this. This is actually our W, and this is our W sub y, W sub y, and this is our W, and then there is our W sub x. And we are having this one as our theta. Now, what can we say about W sub y? W sub y is actually adjacent to that theta. Okay, W sub y is adjacent to that theta. Therefore, we can say W sub y is equal to W cosine of theta because that's adjacent. And W sub x here, W sub x is opposite that angle theta there. Therefore, W sub x is equal to W sine of theta. Okay. Now, if we try to sum up forces, okay, if we try to sum up forces horizontal, if this block is resting and there is no acceleration, for example, it is just resting on that inclined plane, we will be having W sub x equal to the frictional force F, and that is equal to mu n. Now, what is n now? N is actually, if we try to sum up forces vertically and we rotate the axis, we can see that n, which is upward, is actually equal to W sub y, and that is actually equal to W cosine of theta. Okay, so that is just how we solve problems in inclined plane. If in case there is some tension here, okay, so if there's some tension here, you just have to consider this one. And if you're going to apply the Newton's second law of motion, which is F net is equal to MA, okay? So the first thing you do is you assume the direction of the acceleration. So assume the direction of the acceleration. For example, this one is going down. And then all forces here in the F net that is going in the direction of the acceleration will be positive, and the ones that is opposing the direction of the acceleration will be negative. I hope in this case we will able to show the forces that are acting on inclined plane. If in case, let's try to show the worst case scenario. If in case we will be having here a pulley, okay, and it is said that this pulley is frictionless with negligible weight, and there is some block here, okay, there's some block of another mass that is hanging, and this tension here is supporting this mass or the weight, let's say that's weight 2, then we can say that the tension in this cable or in this string will be the same because it is stated that the pulley is frictionless. It will not add on to the tension in the pulley. So the tension here will be the same as this one. Now, what you're going to do? It is very easy and very convenient for you to solve this by making FBD separately, you know. All we have to do is to analyze this one first and then analyze the other one. Okay? In that case, we will clearly see what is happening in the system. Of course, do not forget, you have to assume the direction of your acceleration. If the forces are opposing the acceleration, it will be negative, and forces that are going toward the direction of your assumed acceleration is positive or are positive. Now, if in case you have a negative acceleration or you have a negative value, then it simply means that your assumption is not correct, and you have to change the direction of your assumption. So I hope in inclined plane problems, I have already shown you all the rudiments from very easy with tension, with pulleys, and of course, the application of the Newton's second law of motion. I hope this one will help. This has been your Sir R Squared saying, take care always and God bless. To God be the glory.